Is Gokul Nanda, a final year B.Tech student from Cambridge Institute of Technology. My project is about EV battery degradation reduction. The main aim of this project is to predict the remaining battery capacity and health level using machine learning. Now, first, what we want to do is first we need to load the data set. Here, the data set is battery.degradation.csv. After loading the data set, we need to check whether all the columns are present or not. So that we use this function df.head. After that, to check how many rows are present, how many columns are present. So that I have used this function df.shape. After that, to check all the columns are present, I have used the column names df.column. These are all the columns which are present in my data set. After that, if we use this type function, it will show all the columns and rows what are all present in my project. After that, we need to check the any missing values are present in my project. So while checking the missing values, there are n number of missing values. So in order to remove all those missing values, we should use some methods. By using heat map, these and all the missing values we found. Again, to identify by applying mean value imputation, we will get to know that there are still remaining missing values are present. Again, we need to process the again at final stage what we are good. Again, if we use this function and finally all the missing values will be clear, then we should go for step 3, that is exploratory data analysis. Here what we are going to do is, here we analyze the data and visualize the data is happen. After that, we use hist plot to analyze the data between distribution remaining battery capacity based on the count and remaining capacity of battery. Again, we have compared the charge cycle versus battery degradation using scatter plot. Again, we have compared remaining capacity percentage average temperature using a scatter plot. Again, using hist plot, we have been compared what are all the features are present and what are all the columns present. Again, we have used box plot to compare between the battery remaining percentage and what are the battery types are present. Again, we have used this regression model to predict exactly what remaining percentage is present. This is important because in regression model, we again after selecting the regression model, we have to test and train the model. After that, we have used feature scaling. It is very important to identify how many categorical columns are present. After that, we have applied hard coding. After applying hard coding, this and all the columns which are present and this and all the rows which are shown, which are not having battery capacity. After that, we have to redefine the X and Y from encoding the data. Again, we have to train the data and test the data. After training and testing the data, we have to select the features which are all present. Again, I have used it in regression model. There are several types. That is one, I have used regression, linear regression. After that, this is the output I got. After that, I have used random forest regression. For random forest regression, I have got this. This is the output, and I have used support vector regression. And for support vector regression, I have got the output. Based on this model, we have to compare which model is suitable for our. Again, in fifth step, we have classified the model. That is, we have to predict the battery health prediction. First, we have to check the health. First, we have to create any classes like good, food, medium. These classes were created. Based on this, we have to target the labels. After targeting the labels, we have got the output this. After, we have to train and test the. Again, we have to train the data and test the data. After, we have to select the features. Again, I have used this decision tree classifier to decide the result and to maintain the accuracy. The accuracy I got over here is 0.38%. I have used for in random forest. I got accuracy about 0.38. The same accuracy I got. Again, I have used to calculate accuracy in SVM. Again, in SVM, I got 0.38. Again, by using neural networks, I have bind the blind neural network model. In this model, I have trained this model by using this blind neural network model. After that, I have compiled this model. Again, I have trained this model. In this model, there are 40 approaches. I have trained all those things. After that, I have been evaluate the model. After evaluating the model, we have to predict the battery health capacity, right? To that, I have used this predict model dot sampler. After, we have to compare which model is best for this presentation. This regression model comparison table I have used. Based on this, in linear regression, I have got under 0.-34. In random forest, I got 0.09, and SVR I got 0.27. So we have to compare the accuracy based on this. Based on this, in decision tree classifier, I got more accuracy, that is 0.395, and in remaining all those random forest and decision tree classifier has the same accuracy. In these models, I have to compare the best model, so I have used this best model accuracy. The best model is linear regression model, that is single vector regression. The best classification model is here decision tree. The final, we have to predict the pipeline function, how it will show. Again, in those columns, we have to predict the final function. After to predict the final function, we have to text with an example. I have taken these are the underlying inputs which I am going to pass: the number of charge cycles, average temperature, how much charge rate it should be, charge rate slow should be, charge depth should be 70%, and battery age, how many, and voltage variation. Based on this, it will predict our model. This is the front end for our model. This front end is designed by using Streamline app, by using Cloudflare. After running this, if we go to this, once we entered the charge cycle, that is 400 charge cycles have been charged. The average temperature is 30%, the battery age is 20%, the discharge depth is 70%, the voltage variation is 0.15%. When we use this predict air battery, the remaining capacity will be 76%, and battery health is medium. This is all. Thank you.